Hello, and welcome back to It's a Very Exciting Time, a podcast by a UFO nerd and his tolerant friend. My name is Scott, and I've been fascinated by the phenomena my whole life.
And I'm Chuck. I'm an aerospace nerd and a tolerant friend.
We started this podcast because since 2017, there have been shocking revelations, from news of secret Pentagon programs to confirmed videos of astonishing craft. In a nutshell, now that we know the government has recovered non-human technology.
Or at least we will, once everyone finishes reading Dr. Villarroel's papers. Did I do it?
You did it, Villarroel. You
All
hesitated, but you nailed
I know,
it.
I did. It's like Guglielmo Marconi. Gotta add that to our top. Okay, sorry, carry
It
on.
raises a natural question. If UFOs are real, what else? Suddenly, some of these other parts of the phenomenon that seemed unlikely are pulled into the realm of the possible.
And they may still be unlikely, but even if it's new science and not aliens,
It's a very exciting time.
yeah, it is.
You want to do
Starting
that one
strong
over
today,
again,
Scott.
or are we good?
No, I'm happy. I'm
All
happy.
right, cool. Well, we'll keep going then. Chuck, I've got an exciting one for you today that I think is a little more in your wheelhouse than mine.
Yeah.
So basically, there is an astrophysicist out there named Dr. Beatriz Villarroel, and she has been on the periphery of the UFO community for a while. She's someone we've been aware of, at least since she joined the Soul Foundation that Gary Nolan founded.
Okay.
For those of you who may not remember, the Soul Foundation was something that Dr. Gary Nolan, who we've talked about many times before on the show, we have a lot of respect for him. He started as a way to advance science-driven discussions around UAP. They also write white papers recommending policy for governments, things like that. But the main thing, as Dr. Nolan has said repeatedly, is literally just to destigmatize the UAP topic in the field of science. Now, Dr. Villarroel actually spoke at the first Soul Forum, and she talked about disappearing stars and how they aligned with the Washington, D.C. UFO flap. I watched it, but it didn't make a huge impression on me at the time, but her name kind of stuck in my head as someone to pay attention to. And then, back in July, she started dropping hints about some upcoming UFO-related scientific papers that were in the process of being peer-reviewed. And she tweeted the most baller teaser ever. She said, "We looked where few have dared, and we didn't find nothing."
Which is not the American colloquialism. We didn't find nothing.
Right? Yeah, exactly. So as you could expect, the UFO community started getting very hyped about, another serious scientist paying attention to the phenomenon. And she, I should note, already had multiple papers published, some of them even on this topic, but she was strongly hinting that these upcoming 3 papers were going to be kind of a bigger deal than the earlier ones.
Yeah.
The reason we're talking about her now rather than back in July is back in July and August, she dropped the preprints of those papers. If you're not familiar, like me, with the scientific paper publication process, you need to get your paper published in a journal in order for people to respect it. And in order to do that, your paper has to be peer reviewed. So you'll put up a preprint, which is basically, here's your paper, it's done. You're turning it into the teacher, all your sources are cited, your T's are crossed, your I's are dotted, but it's not yet peer reviewed. And at this point, you'll submit it to journals, referees will look at it, and they may come back to you with feedback. But the idea is at some point, it'll be reviewed by your peers, and they will say, yeah, this is good enough to publish. Chuck, does that align with your knowledge? I know Erica is getting into this world. You probably know more about it than I do.
Yeah, I mean, but I think you're correct to worry about things that are preprint. Like we've been looking at whether Erica could get some of her wet sciences published in bioarchive,
Hmm.
and the answer is like, yeah, undergrads, graduate, independent. You don't have to have a PhD. You don't have to be associated with anything. You don't have to have prior publications. It is not peer reviewed, but it does need to look like a scientific paper,
Right.
and it does need to be somewhat original and not
Hmm.
plagiarism. But
Yeah.
that's
Now,
it's not a
of
big
course,
bar.
there's a weird, awkward tension here around the
Yeah.
credibility of getting published in prestigious journals and things like that.
Mm-hmm.
Um, I'll just go ahead and spoil this here. All three of Dr. Villarroel's papers were peer reviewed and approved and have since been published in journals.
Thanks. Yeah.
They weren't necessarily the biggest name journals. Some of them were, some of them
Mm.
weren't. And she got turned down for being published to, I think it's called X Archive, but it's like the central repository where everyone puts their papers. And they were like, no, these aren't scientifically notable. If you've watched any documentaries or interviews with like Graham Hancock, for example, he proposes an, shall we say, alternative theory of human evolution that involves a high-tech human civilization that was wiped out in the Younger Dryas. Um, and he has all sorts of claims and evidence, but basically he can't get anyone in the scientific mainstream to take him seriously. He can't get his papers peer-reviewed and published.
Mm.
If you talk to mainstream scientists about this, they're like, yeah, because he's a nut job. Like the things he's claiming are bonkers and not worth
Yeah.
evaluating. His claim is the archaeology mainstream is so worried about their tenure and respectability that they're unwilling to look at anything that might rock the boat. I'm an outsider. I don't know the truth on this. And frankly, I wouldn't be surprised if it was a little bit of both. Like, he
Mhm.
is nutty, and his papers maybe don't deserve to be reviewed. But also, there is a bit of institutional inertia and resistance to new ideas. So, when we
Okay.
hear that Dr. Villarroel's papers were published, but maybe not in the most prestigious journals, or they were published but were rejected by the X Archive site or whatever it is that like collects everyone's scientific papers, there's multiple ways to interpret that. One might be that, oh, the things she's claiming are not as grounded and notable as maybe she would like us to believe. Another might be that this is another example of the scientific institution kind of dragging their feet and being unwilling to
Right.
take topics that make them look less credible, because that is, it's a political thing, right? Like science is about
Mm.
money.
Hmm.
If nobody takes your
Yeah.
science department seriously because you publish paper on UFOs, it might be harder to get
That's a
funding in the
problem.
future. I
Yeah.
am I want to be very clear here. I am not staking a claim about which this is. I just want to make the point that there's room for both things to be possible, and I don't blame
Yeah.
anyone who leans one way or another. But for what it's worth, all three of these papers were peer reviewed and were published. So,
Hmm.
with that said, let me rewind a moment because I got a little too into the weeds too fast. Uh, I hesitated to make this episode. I mentioned back in July she was putting up preprints, and I didn't want to talk about it then because they weren't peer reviewed. We're talking about it now because back in October, all three of these papers were finally approved and published, and she's making the rounds and getting a ton of interviews. I still hesitated because, as you may be aware, I am not a scientist. I did not go to brain school.
Science school.
uh, Chuck, while he is a space enthusiast and is very interested in rocketry, is also not a trained astrophysicist. So
Nope.
while this
Sure.
overlaps with our fields of interest, UFOs and rocketry, neither one of us is really a qualified expert. I've
No.
never read a scientific paper. Chuck, I think you said you
Really?
tried to read one of these before and you like kind of stumbled over it. It was a little tricky
Like,
going.
you've never read any of them?
an art major, but
Okay.
literally never had cause
Dude,
to read a published scientific
I
paper.
this is like a weird, I guess this is a weird thing Erica and I bonded over. We do it all the time. Like we
Awesome.
send each other
Okay.
papers that seem interesting from all sorts of fields. So,
Well, if anyone out there is wondering which one is the smart friend and which one is the tolerant friend, I think we just established our bona fides here. But so, point being, I was hesitating to talk about this because the way that
sure.
the
Yeah.
show usually goes is I come in prepped to talk. I've read the
Hmm.
material, I've watched the interviews, I've put together notes and quotes and things like that. And I'm bouncing this off of Chuck, who often is kind of the sounding board for the idea
Hmm.
that I'm bringing, and often the one who's willing to kind of like pull it back a little from my like, holy shit, it's aliens, Chuck. You're like, I mean, maybe.
Wait, hang on. This one's
So
harder though for me to
it is
say
harder.
to pull you back. It's pretty
It's
good.
harder. Yeah. And I was hesitant because I didn't want to read the scientific papers. It didn't seem like fun. Um, so full disclosure, I have not read the scientific papers. What I
Okay.
did was watch multiple interviews with Dr.
Hmm.
Villarroel, where she explained what the papers said in plain English, and I read multiple articles kind of summarizing them. And they all said the same thing. So I feel very confident to talk about the high level overview of it. There may be
Yeah.
details that I get wrong. There may be things that I say that to an astrophysicist are nonsense or don't add up. I encourage you to go read her actual papers because if something's wrong, it's probably my fault and not
Probably
Dr.
us.
Villarreal's.
Yeah. 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 For
So,
sure.
with that said, getting back to the question that was in the script like 15 minutes ago that Chuck hasn't had a chance to ask,
Right.
who is Dr. Villarreal? Have we heard of her before? um,
Yeah.
on the Soul Foundation website, her biography says that Dr. Beatriz Villarroel is a researcher in astronomy at the Nordic Institute for Theoretical Physics in Stockholm. She leads the
Nice.
Vanishing and Appearing Sources During a Century of Observations project, or VASCO. The VASCO project searches for vanishing stars with the help of automated methods as well as a citizen science project.
It's cool. Super cool. Um, so I think there's a lot of different definitions of vanishing stars. And her
Mm-hmm.
story about how she started looking into this is fascinating.
Mm-hmm.
Um, thank you to the Discord, by the way, for sending us links. The interview with Gary Nolan is just top notch.
Yeah, lots
But
of links in the show notes, by the way. Links to all of the
yeah,
papers, links to all the interviews. Yeah.
yeah, as usual. So in this case, which definition is she talking about? What is a vanishing star for the purposes of the next hour
Sure.
podcast?
A better term is transient. And literally
Transient.
what they mean is they're looking at a survey of the sky, which is lots of photos taken of the sky, long exposures. And if there's a star that appears in one photo, but not another, that's a vanishing star. It's a transient. It's there and then it's not there.
Mm,
There's a lot of reasons why this might be. We're going to talk about a lot of them, but that's kind of her field of interest. Why are there vanishing stars?
okay,
Stockholm
so
University. Sorry, go ahead.
yeah, so I just want to clarify one thing. So she like on the website, the Vasco website, she has a one of the plates, like a picture of one of the plates, and it has like an alignment on a single plate. So it sounds like there's kind of two kinds of transients. There's ones where it's like reflecting multiple times in the same plate, and then one where it's there in one plate and not there in the next plate or like the next days. Is that right?
We're going to get into this, but the
Okay,
short
all right.
version is vanishing star or transient literally just means it's there in one and not in another. That
Okay.
may factor in things like alignments and things like that. That's what makes some of these transients more interesting than others. But yeah,
Mm,
we're gonna talk a lot about this. This is the meat of what her papers are about, in fact. But to
okay.
kind of get back to your original question, the Stockholm University press release about her papers being published says,
Okay.
vanishing stars are short-lived flashes of light captured on photographic plates that look like stars appearing and disappearing within a single exposure. For a long time, single points of light on astronomical plates have been dismissed as defects, even when they looked like real stars.
Huh. Yeah. So do they talk about what, like, okay, I've never developed film. I don't know what can go wrong. Do they talk about what a defect is?
Sure. Now, this is one of the things that I am interested in. I took a lot of photography classes in
Okay,
high school and college. I have been in darkrooms. Um,
cool.
but yeah, defects are exactly what you assume. Photography is a chemical process. Things can go wrong in chemical
Mm,
processes. You've probably developed photos before and seen like little specks. Like in a digital camera,
mm,
you would see like a dead pixel in the screen, but in film
sure.
photography, literally there can be like a thick spot in the emulsion or a scratch on the negative. Anything. The point is, you're looking at a photo of the sky. There's something there that looks like a star. If it's not a star, one answer is it might just be a defect in the photo. It's
Okay.
somebody poked a hole in the negative and it behaves like a star, but it ain't.
Okay. Um, so similar question. I've done like high ISO digital captures and
Mm-hmm.
like dark spots of the photo get like all weird and wiggly. Does
Mm-hmm.
high ISO like actual film do that too? Like get blotchy?
Um, yes, it can, short version, but the
Okay.
the more important part is these are long exposures that we're talking about. So any anything like that you would not expect to come through. And you can, in fact, go to the website, as
Oh,
you've said, and look at the photos that come through. Now, we'll talk about this a little more. These are not the highest quality photos. These are old photos that were scanned a long time ago, but they're effectively black and white photos of stars. And sometimes there'll be things that are obviously defects, like a scratch or a little like rip in the corner or
mm,
something like that. But most
okay.
of the time, what they're talking about is literally you look at three photos taken in a row, and in the first one, there's nothing in this spot. In the second one, there's a star in that spot. And in the third one, there's nothing in that spot. That's mostly what
Interesting.
they're interested in. Things that look like stars and don't have an easy explanation, like, oh yeah, we know that a meteor flew through the sky at that point, or we
Right.
inspected the negative and in this case the negative was damaged or something like that.
Sure. Okay. Cool.
But yeah, what it boils down to is there's a big collection of stars. There are some oddities. There are vanishing stars, and most scientists dismiss them as defects. Like they're literally
Sure.
filtered out of the data sample when you request the data from these plates. Um,
Okay.
the process of what they got these photos from is actually really interesting. So I want to talk about that for a minute.
Yeah.
Scientific American wrote an article about it, and they said Villarroel's papers concern data gathered at the Palomar Observatory in California from 1949 to 1958. Those dates are significant. We'll talk about them later, but
Yeah.
for a project called the Palomar Sky Survey, which was one of the first detailed astronomical surveys of the sky. About 2,000 photographic plates were used as part of the survey.
Okay. What is a photographic plate? You've said it a couple times.
Mm-hmm. Yeah.
Is it like
So
film?
if you are familiar with like film photography, before we
What?
had film, which is a roll of like cellophane with emulsion on it,
Yeah.
literally photographers would have a sheet of glass that you manually applied emulsion to in a dark
Oh,
room.
no way.
Emulsion is a
Okay.
chemical that reacts to light. So you put
Okay.
this piece of glass with emulsion on it inside the camera. You open the shutter to expose it to light. Some of the emulsion turns dark, some of it turns clear based on light or shadow. Then you develop it. The development is literally going again into a darkroom and putting it in a chemical bath that sets the emulsion so it won't
Yeah.
change anymore. And
Okay.
from then on, you have a photographic negative. We do that now with film. Back in the day, you did it with plates
Hmm.
of glass. These are like kind of extreme though. So
Yeah.
these are like telescopy. That's not a word. Rocketry. What am I thinking of? Like for use in telescopes. They're big. They're
Sure.
big sheets of glass.
Okay.
Um, each photographic plate was a glass sheet coated in an emulsion or a layer of chemicals that reacted to incoming light, mostly from stars across the sky. This was the main method of recording astronomical images before the advent of digital cameras. Each photographic plate was the size of a vinyl record cover and was physically
Whoa.
lifted into and removed from the telescope after it took a 50-minute exposure of the night sky.
Okay. Cool. Um, so when I think about it, I'm thinking about current day NASA, where those plates would be like sweated over for 3 years at great expense. But I think 1950s NACA was a kind of different place. I think it was still probably super high quality, though, right? Wouldn't you imagine?
It was the highest quality that they could get at the time.
Sure.
Nowadays, it
Okay.
is not particularly high quality, but it's also worth noting that for looking at stars in our night sky, you don't need an incredibly deep, like high quality photo. It'll bring out more, but at the end of the day, a
Yeah.
star is going to look like a star. It's going to be a point of light in your
Got
photo,
it.
whether you have a very high
Yeah.
resolution camera or kind of a crummy camera. A higher resolution
Yeah.
camera will theoretically capture smaller points of light that maybe your older camera couldn't have. But
Yeah.
this was the
Okay.
cutting
Cool.
edge in the 40s and 50s. It's also
Yeah.
worth noting
S
that Palomar Observatory is not the only place that was doing this.
Oh, cool.
Dr. Villarroel had another interview with Jesse Michaels. I've talked about Jesse Michaels before on the show. I have mixed feelings about him. I love the
Yeah.
films that he makes. I think he's a very enthusiastic guy who's bringing a lot of attention to the topics. Full respect for that. I find his interviewing style somewhat exhausting.
Mm.
And he has a tendency towards conspiracy theory thinking, which I can't fault him
Mm.
for, but it means that there is a lengthy cutaway in the middle of the interview with Dr. Villarreal where he talks about Don Menzel, who ran the Harvard Observatory at the time, who was a noted UFO
Mm.
skeptic, who at the time destroyed 1/3 of the photographic plates that the Harvard Observatory took. Wikipedia says this was for budgetary reasons. The UFO conspiracy theorists, of course, believe that he carefully destroyed all of the plates that had any evidence of UFOs. It doesn't make a whole lot of sense to think that he destroyed all the ones at Harvard when other observatories were still taking the photos, but it remains a weird thing that UFO people are kind of fixated on. It doesn't
Okay.
actually affect Dr. Villarreal's research at all, though. So it was this kind of weird conspiracy themed
Hmm.
detour in the middle of, like, oh, the photographic plates, where's the evidence? In this
Yeah.
case, Dr. Villarreal had access to the plates from the Palomar Observatory,
Okay.
which is another civilian observatory.
Got it. So, okay, getting back to it, that must have been an absolutely monstrous negative, though. Like, if it so
Yeah, size of a
35
vinyl
millimeter
record. Yeah,
film,
it's big.
right? But like 35 millimeter film is 864 square millimeter.
Huh.
But 315 by 315 is 99,000. That's like 114 times bigger
Yeah.
area. Like, how do you even like with a 35 millimeter? I can like look at it through
Mhm.
the light, but how do you inspect something that's that big and that detailed? Like,
That's a
did
really
they?
good question. No, totally.
Yeah,
So we've been talking about physical glass plates, and it's reasonable that you
yeah,
might be assuming that they're out there with a little like jeweler's loop, like looking at the individual glass plates.
yeah.
These plates were digitized in the 90s and 2000s. So they're looking
Okay,
at a data set of digital images scanned from these negatives. They
Okay.
used, this is from Scientific American, they used image processing software to look for transients, which are short lived celestial events, such as stars flaring in brightness or fading from view, that are often associated with extreme astrophysics.
Hmm.
Love that term, by the way. Uh, they identified
As if it
more
isn't
than,
all.
I know, but this is notable, I think. So remember, there were 2,000 plates. They identified
Hmm.
more than 107,000 transients.
Wait, so if there were 2,000 plates and 107,000, doesn't that mean there were like, what, 50 per plate?
Yes.
That's wild.
Yeah.
Okay. Interesting.
Now, again, we're going to talk a lot about why scientists dismiss most of these
Yeah.
transients. But
Sure. Okay.
yeah, they found a lot, is the point.
Okay. Yeah. So if these were digitized, like I remember scanners in the 90s and
Hmm.
2000s,
Yeah.
aren't these like, can it be grainy messes? Or,
I don't know
I
about
don't know, is
grainy,
it
but they're
good
certainly
enough?
not super high resolution. As Chuck
Okay.
mentioned earlier, you can go to their website and look at these images whenever you want. They're open to the public. And yeah,
Yeah.
like a star is like anywhere from 3 to 15 pixels. Like it's
Mm-hmm.
not a super, super high resolution. If you're used to looking at like James Webb telescope images, like this ain't that. These are older.
Yeah. Okay.
And yeah, maybe they would benefit from higher resolution things. But something that I think is worth noting is this is just a single free, already digitized data set that was available to them. And they're mostly using
Makes sense.
computers to look at them rather than people.
Mm.
One
Yeah.
of her
And
points
computers
is
don't care.
this process can and should be applied to other observatories' photographic plates from the era. She even put out a paper talking about how you could take some of the techniques that they developed and apply to today's night sky images. There are,
Hmm.
of course, different challenges now with like 150,000 Starlink satellites up there, but
Yeah.
there are techniques that she suggests that can let you discount most of the modern tech and sky junk and look for the generally weird stuff. And again, this is kind of her
Very cool.
goal is yeah, there's extreme astrophysics like supernovas. There are things like meteors making fireballs in the sky. But even when you take all of that stuff out, there's still a lot of these disappearing stars. What could explain it? Well, full disclosure, her hypothesis is that some of them are artificial bits of technology that are up there. So if that's your
Yeah.
hypothesis, you start looking at how can you either find some evidence of that, or at the very least, how can you knock down some of the common arguments against it? So the
Yeah.
most common argument that they get is you're looking at space junk, you're looking at satellites, you're looking at solar flares, you're looking at like all these things we know about.
Mm-mm.
Um,
But that's why
so
the dates, right?
yeah, so basically what they start with is a filtered set of unidentified transients. They have, to my understanding, they have already done things like removed anything that is a supernova that they already know about. Like, oh, this one
Right.
that appeared on this plate, that's supernova X. We know about that, so we can discount that.
Right.
Um,
And pulsars and magnetars and
exactly.
all those like pulsing things. Okay.
Yeah. The other thing I mentioned earlier that the date range when they conducted the survey is important because
Yeah.
all of these photographic plates are pre-Sputnik. They exist
Oh,
before humans have put anything in space. Dr. Villarroel said, today we know that short flashes of light are often solar reflections from flat, highly reflective objects in orbit around the Earth,
mm.
such as satellites or space debris. But the photographic plates analyzed in Vasco were taken before humans had satellites in space.
Okay. And so 1958 is when Sputnik and some of the first US ones got launched. Okay. Um, so they, okay. So they've got this giant list of transients. How do you get from there to like real objects that aren't plate defects? Like she
Yeah,
talked about the technique. What was it?
absolutely. Yeah. So again, she's coming into this. We've got a big list of transients. We've eliminated all the ones that we know we can explain. We know that they're not satellites. So what? Well, most astronomers say these are plate defects, and they think no further about it. She says some of them are plate defects. I don't think they all are. So one of the first things they did, Stockholm University press release again. So sorry, I don't know if you can hear that. My cat's automatic feeder just went off. I just bought that. So
oh, hey. No, I couldn't.
Something I didn't think about happening while we were recording. Stockholm University said the researchers looked for instances where multiple flashes of light were along a line or in a narrow band, something that indicates reflections from flat reflective objects in motion. Dr. Villarroel further explains, she says, something could be in a narrow band either because it is tumbling in space when it's in orbit, which results in successive glints as it moves along, or it could be that you have something that is in formation. These are all single glints, but from 5 objects that are flying in a line.
Yeah. So, like, I think she's getting at, like, emulsion defects aren't going to be, like, in a line. Exactly. But there's a lot of physical things, like bottle caps, or accidentally scraping it against. No, I mean, like, something scraping the plate.
Yeah.
That could be in a line.
Yeah.
So, like, I think this point is about the emulsion defects.
So there's 2 points here that I think are really important to make. One is they are only looking at things that look like stars. They are not looking at streaks or lines or anything that might be a meteor, that kind of thing. They have already filtered the data set down to there was a star-looking thing on this plate and not on this plate. Another thing that's notable is I don't understand the science here, but they have something called a point spread function that helps them identify which of these things are star-like. And that has to do with basically what a human would notice. A star looks like a very bright light that kind of fades out, and it might have the little, like, cross beams coming off of it. A scratch from a bottle cap or a puncture mark in the emulsion, things like that, aren't going to match the point spread function. Again, I am absolutely running the risk of getting into dangerous territory here, talking about something I do not understand. But the takeaway that I got and that I want to give to you guys is they were able to eliminate anything that doesn't look like a star already from their data set. That doesn't mean that there were no defects in here. Absolutely. Some of these could be defects. So one of the first things they started doing was defects are unlikely to appear aligned or in formation. So let's look for that. Let's look for, things like a bunch of them sequential in a row, like you'd expect to see from a satellite tumbling overhead. And they found a bunch of them. They found anywhere from 3 in a row to 6 in a row. In a couple cases, they found them kind of clumped together in a formation. And again, they're not saying this means it's a UFO. They're saying this is another signal that gives us confidence that it is probably not a plate defect.
Right. This is something weird. Okay, cool.
Now, if you're feeling a little skeptical, which I don't blame you, when they went to publish their paper, one of their peer reviewers felt the same way and said, okay, but you still need to prove that it's actually a solar reflection. So if that's true, the solar reflections are going to vanish in the Earth's shadow.
Okay. I think I'm picking up what the peer reviewer is putting down. So over the course of a 50-minute exposure, you might catch multiple glints of light, or it might be different between the two. But if you can grab if one of those exposures has the Earth's shadow in it, the Earth won't block out any actual stars. Like, its shadow just isn't big enough or interesting, like powerful enough to block out a star. But if it was...
So if her hypothesis
receiving light from the sun,
these vanishing stars are not solar astrophysical phenomenon like stars and solar flares and
Yeah.
supernova and shit like that, but are in fact something in orbit when there shouldn't be anything in orbit, then
Yeah.
if your argument is that these are solar reflections, you would expect they would disappear in the Earth's shadow. A real brief summary for anyone like me who maybe wasn't paying a lot of attention in astrophysics class, if you took anything like that. The sun is bigger than the Earth, so when it shines light on the Earth, it casts a shadow into space, but that shadow isn't straight. It's a cone.
Yeah.
So
Right.
in scientific terms, they call that the Earth's umbra. But basically, there is a cone directly opposite the sun that is the Earth's shadow. Nothing in that shadow should be reflecting solar light because there isn't any solar light for it to catch in that spot.
Right.
It's not 100% perfect. You can get glints off of like moonlight and stuff like that. If you yourself are in the Earth's shadow, but because it's a cone, the thing you're looking at is technically outside the Earth's shadow, you might still see it. But the point is,
Right.
Dr. Villarroel says, for every transient, we have the coordinate and we also have the time of observation. So you can calculate if it is inside the Earth's shadow or not. If it would be plate defects, you would expect that there would be no deficit, meaning here's the total number of transients we spotted, and there is no change in the number of transients in the Earth's shadow. It's still the same number. On the other hand, if it's all solar reflections, you would have no transients appearing in the Earth's shadow. And if you have part of them are real and part of them are plate defects, you'll have a deficit. And you can basically estimate how big a fraction of your objects seem to be authentic based on that deficit.
Okay. So I struggled with the word deficit here for a long time, but I think what she's saying is that if we assume that these are all defects, which lots of scientists have before, then if we find any that disappear in Earth's shadow, there's a mismatch in our expectations.
Exactly, because you would expect plate defects to be evenly distributed statistically.
Right.
So and of course you have to be talking about numbers that are statistically significant. If we're talking about 12,
Sure.
it doesn't matter. But, as we said earlier, they're talking about hundreds of thousands. So if you've got that many defects, and a certain percentage of them are in the Earth's shadow, and we know which ones should be in the Earth's shadow, then we can expect a certain percentage of them to be there. If they're all defects, there should be zero deficit. If they're all solar reflection, there should be 100% deficit. And if it's any percentage, some are defects, some are real physical objects, then there'll be a number in between. And as you can probably guess by the fact that we're talking about it, they found an interesting number, which is, Villarroel says, we see that there is a deficit of 1/3. It means that 30 to 35% of the objects that we're working with come from solar reflections. And I think this is an important point because they're not talking necessarily about just limiting their sample to the Earth's shadow. What they're saying is, this deficit says that in the Earth's shadow, we see 30% fewer transients than we expect. That tells us if you extrapolate out to all of the transients, probably about 1/3 of them are real objects that are solar reflections, and that's why we don't see them in there. So she is not saying all the transients are real. She's still saying like something like 70% of them are not solar reflections. Right. But just by the Earth's shadow test, she's saying 30% of the transients we detect by statistically are likely to be real objects casting from a solar reflection.
Okay, so she's not saying that 30% of 107,000 were in the Earth's shadow and disappeared. She's saying of the ones that were in the Earth's shadow, 30% of them disappeared.
Yeah,
and
basically, if you
extrapolating that.
compare a sample from in the Earth's shadow to
Mm,
out of the Earth's shadow, there was a 30% deficit.
got it.
Assuming that means real things, you can extrapolate that out. If 30% of them statistically disappear in the Earth's shadow, then 30% of them that we still see outside of the Earth's shadow are real objects from a
Interesting.
solar reflection. Yeah, it's fascinating, right?
Yeah. Okay.
Because
And
there shouldn't be anything up there.
right. Yeah. Yeah.
There
Yeah.
certainly shouldn't
So,
be thousands of them.
right. So extrapolating that number out could be problematic, but
Yeah,
let's assume it's right.
sure.
Why couldn't that be a meteor or something else natural?
Sure. That's a great question. And I want to be very clear before I answer this. This is an ongoing debate. We'll get to the section
Hmm,
later where we get alternative
cool.
hypotheses being proposed by the community and other scientists. You are not
Okay.
alone in looking for natural answers to this that don't
Yeah.
necessarily take you to UFOs. But her answer is Villarroel says only something that is planar, meaning has flat surfaces, and is highly reflective can give off these transients. Any round or rough body, such as a meteor, would result in a streak. These flashes
Hmm.
that we see are not streaks. They're associated with things that are extremely flat and extremely reflective. I'm thinking mirrors, glass, or polymers.
Okay. So shiny and flat, like a solar panel,
Yeah,
is the
exactly. Although, again, pre Sputnik, there shouldn't be any solar panels up there.
no.
More
Yeah.
interestingly, for our audience, this also describes flying saucers. The flying saucers that were described in the 50s were very
Yeah.
often saucer shaped things with a flat bottom that were highly reflective. Merrick
Hmm.
von Rennenkampf, a UFO journalist, was talking about this. He said, the earliest U.S. government analysis of UAP, dating back to the late 40s and early 50s, all describe metallic or light reflecting objects. I'm cutting out a lot here because we've already talked about this many times in the show, but he goes on to cite Kenneth Arnold's original UFO sightings in Washington, the 1947 Twining memo, the 1948 Air Force analysis. If you're interested in any of these things, go back to our episode on the Arrow Historical Report, where we talk about a lot of these papers that were released. But the short version is the government put out many memos and documents in the 40s that were internal that were saying this is a real phenomenon. The people who are seeing it are not crazy, and they are consistently describing these metallic reflective objects that are flying in the sky. Merrick goes on to say, it should be noted that many witnesses also described metallic light reflecting objects exhibiting bizarre, erratic flight characteristics, such as wobbling, oscillating, and flipping. This is one of the weird
Hmm.
things about UFOs. They don't fly like aerodynamic objects. Excuse me, aerodynamic objects have a very predictable flight path. They have to move
Right.
in the way that the air flows over them. So you don't see a lot of wobbling. If you've got a plane wobbling in the air, something is going very badly wrong, and it's not going to be in the air
Yeah.
for long. um, UFOs often kind of wobble or weave or kind of like jump around. They even flip over in weird ways,
Hmm.
and not like aerodynamically flip over. They'll like go belly forward all of a sudden with no change in velocity. Um, a recent example of this isn't all dating back to the 40s or 50s, is the gimbal
Yeah.
video. You can watch that one, and it shows a UFO just rotating as it flies along with no change in
Hmm.
how it's moving. So anyway, I don't want to read too much into that, but it is interesting that she's saying the science shows us that maybe a third of these transients are real objects reflecting sunlight. And due to the science that I don't 100% understand, but she describes in her papers, we know that in order for us to get the kind of point source lights we're getting, they have to be flat, highly reflective bodies.
Right.
And they might be tumbling through space, because if it was consistently catching the sun, you would get a streak. So what you're getting is a point source as this like angular surface orbits overhead and catches the sunlight for a brief moment, causing a flare, and then blips out of reflecting directly on you. That leads to seeing it several times in a row if it's tumbling, or it might just be a single point source if it's stable. So it's fascinating that what she is observing happens to align with the descriptions we get of UFOs. Although I'll point out, she's not saying that. She is just saying what this describes is a flat, reflective body moving in space.
Right.
And
yeah, I think
I didn't include a quote about this, but she's also able to determine the altitude. Because again, if it was too high, it wouldn't be bright enough to register on the film. And if it was too low, it would streak. In order to get a point source reflection like this, it has to be at this certain atmospheric band. I forget where.
Okay. So that makes a lot of sense. Like, it's not just like a random thing. It has to be really reflective to look like a star.
Yeah.
Otherwise, it's going to look like something else, or just a dim thing. Okay.
Yeah. And I assume, although I don't know this, that other things like meteors are captured in these photographic plates, and they do know what they look like. Like, oh yeah, here's this streak here, and we know from records that that's this fireball that was seen over Minnesota or whatever, you know.
Yeah. Okay. I mean, that's at least thought-provoking. I'm not sure that I believe that it's UFOs yet. Did they connect those dots?
Yeah. So here's the really interesting thing. So Dr. Villarroel's progress on this has been really interesting. As Chuck said, I recommend you go listen to the interview with her and Gary Nolan. She comes at this from an interesting angle, but basically she starts from why are there disappearing stars to, okay, a lot of them are astrophysical phenomena, but then even when you remove them, there's still thousands of items. Okay, well, what are all of those? And everybody else is like, oh, they're plate defects. She's like, I don't think they're all plate defects. As a hypothesis, what if some of them are, you know, real objects in orbit at a time when there shouldn't be anything in orbit? Well, in order to give any evidence of that, you have to show that they disappear in the Earth's shadow. Well, hey, guess what? A third of them do. That's her research. There's another paper, so that covers two of the papers.
Okay.
Dr. Villarroel says, Dr. Steve Brule and I investigated whether pre-Sputnik transients statistically correlate with atomic bomb tests and historical UFO sightings. And the answer, yes to both.
That's, out of curiosity, was this the one that got rejected from archive?
They all did. Yeah.
Oh, okay. Okay. So how strong is the correlation?
I'm going to be honest here. They admit the correlation is weak, but it is statistically significant. So there's a lower bar beyond where you can even talk about this. It crosses that threshold, but it's certainly not as strong a signal as a third of the transients disappear in the Earth's shadow. Dr. Brule said, out of those 2,700 days, if there is no nuclear test, there is a transient on 11% of those days. But if there has been a nuclear test the day before, then almost 19% of those days have a transient. So that 11 versus 19 is about a 68% increase in risk for a transient if you have had a nuclear test.
I don't like these stats, but
they admit they're not strong stats. They're statistically meaningful, but that isn't like crazy strong.
Yeah. So, all right. My big complaint though is like nuclear tests cause all sorts of weird crap all over the Earth. High energy particles, like this weird stuff.
You are not alone in thinking this. Yeah, we'll circle
how does that
back
relate
to
UFOs?
Concern. We'll absolutely circle back to that concern because the concern that other scientists have is it's not that that nuke tests are bringing UFOs. It's that nuke tests are causing things in your slides that look like transients. They have an answer for that. It's up to you whether you find that answer compelling. but certainly it is a question that a lot of people kind of immediately ask, like, hey, you're telling me you see more of these things the day after a nuclear test. That in itself causes me to question the data, because a nuclear test is a weird, unusual event, as opposed to
Yeah.
that means that it attracted something. It's more likely, Occam's razor, that it did something to your sample.
Yeah.
But
I
there's
guess
a second thing. Sorry, go ahead.
yeah. The thing I'm actually, well, wondering about the nuclear part, but the thing I'm actually more worried about is that if you search a large enough search space and try and find something straight, you will. Um,
Sure.
there's a mathematical function about how many points you need in order to guarantee that you find the pattern you're looking for.
Yeah.
And the number of nuclear tests is small enough that that kind of increase could just, like, we could almost as easily say, like, there's a 68% increase on Tuesday.
Yeah.
Like, and it might be just as valid.
It is very easy to lie with statistics. The only response I will give you is, again, I haven't read the paper, but in the interviews, they presented this confidently as a weak but statistically significant signal.
Okay.
That is the extent
Fair.
of the emphasis that they put on it. And Dr. Villarroel has a point that we'll make later in the episode that basically boils down to, it's easy to explain one of these factors these transients have away. But when it has all of these things, when they disappear in the Earth's shadow, and they're statistically more likely on nuke days, and they're statistically more likely when there's a UFO report, and this and that, it gets harder to dismiss them as any one thing. But we'll get to that later.
Yeah. Okay.
I will just say you are far from alone in thinking, hey, a correlation with nuclear tests is not necessarily an argument in your favor.
Right. Okay, so what about UFOs?
Yeah, so this is the one that I think is really interesting. So he also pulled together a data set of public UFO reports at the times. And this includes things like the Washington, D.C. UFO flap, and basically anywhere where there were public reports of UFO sightings. I want to note the nuclear tests and the UFO reports were worldwide. The telescope is in Palomar, California, on Palomar Mountain, California. So if there is a nuclear test in, Russia, and then we see a UFO in California, is that significant? I don't know. The fact, all they're trying to say is we are statistically more likely to see a transient after these types of events. So taking this UFO data set, he said the number of transients also increases by an average of 8.5% for each report of a UAP. When both these reports and nuclear tests coincided, the effects were additive, with more than twice as many flashes of lights as on days without either nuclear tests or reports.
Okay. I mean, it's interesting, but we're just so far in the law of small numbers. So if I'm doing the math right, double is 22, and we were previously, double 11 is 22. Previously, we were talking about 19 was the nuclear. And so that seems like the extra transients on UFO days was just increased by 3. It's not huge, but I guess on the other hand, it's such a small search space. Like, the numbers are always going to be low. There's not much they can do about it.
The thing that I think is interesting is that they found any statistical correlation at all. Like, if you think these are natural objects, there wouldn't be any correlation at all. The fact that they argue they might be UFOs almost doesn't factor into it. Simply the fact that there is a correlation, however weak, is interesting enough to warrant further study. And I want to point out that Dr. Villarroel's takeaway here is not, I have proven there were UFOs in orbit in 1952. It's
Right. Yeah.
absolutely not what she's saying. What she argues for is there are many other astronomies, observatories, that
Yeah.
did similar sky surveys that have plates. Most of them haven't
Yeah.
digitized them, so they didn't have access to
Hmm.
them. But this would be a great project for a postdoc with an undergrad to go to this
Yeah.
observatory and run the exact same experiment on their plates and see
Hmm.
if we see the same thing. That's where the reproducibility comes in. Effectively, she is describing a number of tests that can give us some confidence that these are not all plate defects, as we previously argued. And if they're not all plate
Right.
defects, what does that mean? Well, that's the next question to dig into.
Yeah. That's cool. That's a
Getting
great
back,
idea.
yeah, getting back to the UFOs for a minute. One of the things that stands out, and of course, correlation doesn't mean causation and all that, but Merrick von Rennenkampf and Dr. Villarroel point out, intriguingly, one of the most statistically significant alignments of transients was captured on July 27th, 1952, which coincides with the second weekend of the well-known and very well-documented July 1952 UAP incidents over Washington, D.C. We've talked about this before, but as Merrick says, this was when multiple radar facilities, pilots, and ground observers all saw objects behaving in perplexing ways over the course of 2 successive weekends. There were newspapers put out at the time that were describing, effectively White House, UFOs land on the White House lawn. The public was concerned enough that the Air Force had to hold a press conference addressing it and saying, to the best of our knowledge, this isn't ours. Because everyone was like, oh, this must be a secret U.S. plane. And they're like, no, it wasn't. The Washington, D.C. flap is very interesting. The fact that it happens to align with one of their aligned transients is curious, not necessarily meaningful, but it's getting back to this idea of why are UFO people intrigued by this paper? It's because she's describing things with the characteristics of UFOs as they were described that align with UFO reports of the time, and there is a known link between UFOs and nukes. This is a well-known thing. Lou Elizondo has talked about this. There's a famous book called UFOs and Nukes by Robert Hastings that I recommend everyone check out. If there is an alignment between UFOs and nukes, it isn't that surprising that they might show up to observe after a nuclear test. But again, we're getting into reading into the meaning, which is not something Dr. Villarroel is doing. They're just saying, hey, we've got this collection of transients. We're operating from the hypothesis that some percentage of them are real objects. And here are the tests, the experiments that we ran that give us confidence that some of them are real objects. Because if they were all plate defects, there should be nothing happening with the Earth's shadow. There should be no correlation to nukes and UFO reports, certainly not the two at the same time.
Right. Yeah. Yeah. I mean, the whole Washington, D.C. thing, that if it's aliens, that sure does make a lot of sense.
So they've done all this research to satisfy their peer reviewers, right? Like they keep coming back with more evidence to make their peer reviewers happy. Another scientist,
point, right?
Yeah, right. Another scientist joins on and finds some interesting correlations, and they're now able to make some interesting claims. Dr. Villarroel tweeted very recently on October 20th. She said, "Our papers are now peer-reviewed, accepted, and published, and they reveal some extraordinary things. First, we find statistically significant correlations between short-lived transients in pre-Sputnik sky plates, UFO sightings, and above-ground nuclear tests. Second, we show a 22 sigma deficit of transients inside Earth's shadow, which is consistent with a fraction of these events originating from solar reflections from flat, highly reflective surfaces in orbit before the human space age began. That's 3 independent high-level journals and 3 independent peer review processes.
That's cool. Can we get a refresher on sigmas?
Oh, Chuck, you are being so generous by saying refresher. I didn't know what the fuck a sigma was.
Okay.
Gary Nolan and Beatriz Villarroel had a very brief discussion about this in their interview that answered nothing for me other than it's a confidence interval. So I chalked it up to something about stats and thought nothing about it until I put the notes together and went, I have no idea what this means. Why is it meaningful that it's 22 sigma? So I went on a little rabbit hole, very little, because I'm still not very smart about this stuff. But one of the references I found when I was Googling 22 sigma was articles written back when the Large Hadron Collider proved the existence of the Higgs boson. They were looking for a threshold, a sigma rating of a certain level to make people confident that they hadn't just found evidence, they had found it. Like, you have to be this confident to be able to say, yes, it's real. CERN said a result that has a statistical significance of 5 sigma means the almost certain likelihood that a bump in the data is caused by a new phenomena rather than a statistical fluctuation. In most areas of science that use statistical analysis, a 5 sigma threshold seems like overkill. In a population study, such as polls for how people will vote, usually a result with 3 sigma statistical significance would suffice. However, when discussing the very fabric of the universe, scientists aim to be as precise as possible. 5 sigma is considered the gold standard in particle physics because it guarantees an extremely low likelihood of a claim being false.
And they got a 22 sigma.
Right. To give a point of reference, I was trying to grapple with how big it is, because when they're talking about like a 5 sigma level of confidence, they were like, there's a, and I forget exactly how many zeros, but it was like a 0.0000006% chance of this being wrong. Like, it was a very, very low. 22 sigma, what even is that? One example I found, someone said that a 22 sigma event, and they showed the math where they got this, is the equivalent of flipping a coin and having it land on its head 500 times in a row. Like, it's just jaw-droppingly
too
unlikely.
Low.
It might
I think
be,
that actually still might be way, 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 way too low.
Sure. When Dr. Nolan asked Dr. Villarroel for an analogy, a plain spoken analogy, she said it's a bigger chance that you get eaten by a black hole tomorrow than that you land on that value by chance.
Yeah. So I'm gonna use Gary Nolan's response to that, which was that 22 sigma is too good.
I don't
my
remember
understanding,
saying that.
Yeah, my understanding was if it's above 5 or 6 sigma, it is more likely that you have picked a bad statistical model, you've made an error, or you've filtered out too much data. And so I am actually a little surprised that she's touting 22 sigma as a good thing, because usually that's an indicator that you have kind of screwed up.
So 2 things. One, I come back again to the fact that these papers have been peer reviewed at this point. So
yeah, right.
If it was something like that, presumably the peer reviewers would also be like, whoa, hold on a minute. So I assume they have math to back this up. But the other thing is, she mentions that the result freaked her out. Now, she didn't put it in terms of this is too good a result, but she was like, whoa, really? Like, what does that mean? Like, I don't think she was expecting a number that equated to 30% deficit in the Earth's shadow numbers. They asked her at one point what was the sigma confidence of the correlation with UFOs and nukes, And that was
Mhm.
when she was like, yeah, it's a little weaker. She said, as I recall, it was like a 3 sigma. But she made it clear
Mhm.
she wasn't sure. And again, I didn't read the paper, so I don't know for sure what it is. But just
Yeah.
as an illustration of how much more statistically confident they are in the Earth's shadow result compared to the
Yeah.
correlation. Correlation doesn't mean causation. Correlation is interesting. It is a
Yeah.
good thing to note because you would expect zero correlation. So finding any, even weak, is very interesting. Finding an
Yeah.
incredibly strong signal that transients disappear in the Earth's shadow is really interesting.
Yeah. I need to review this again. There was a great video put out by either Astrum or Cool Worlds about the difference between sigma and p values and
Sure.
how sigma can lead you astray.
Mm-hmm.
Um, but I need to watch
Yeah,
that
and
again.
I think for me, we'll get to this at the end. The most important thing is they don't have one or two things that say this might mean this. She comes up at the end with a list of 7 things that any alternative hypothesis has to answer. So we'll get to that. But first of all, let's talk about the community reaction. So we saw a
Yeah.
number of people come out very excited about this, which um, admittedly, a lot of these were like YouTube science personas who, they want clicks. They're going to say things to get people to watch. You can take what they say at face value or not. But given that the standard response from the scientific establishment for anything UFO related is like outright dismissiveness, the fact that there was
Yeah.
any positive recognition at all was really encouraging. But as you might guess, a lot of people had alternate hypotheses about what these transients could be. And I just want to kind of quickly go through a few of them here. First of all, a bunch of people, including Sean Kirkpatrick, suggested that perhaps some of these transients were spy balloons from things like Project Mogul or Project Genetrix. Um, there are a bunch of reasons why that doesn't line up, including dates and altitudes, but Dr. Villarroel's direct response to that was during a 50-minute long exposure, any balloons would leave streaks in the images, not point sources.
Yeah. I actually agree with that. Like it would take a lot to not be a streak or just a wiggly mess, like if it was
Right.
tied to the ground. Um,
Mm-hmm.
it would have to stay in place perfectly for 50 minutes and then be wiggling a mirror.
Yeah.
Like
Which
that's
is
a lot.
itself an interesting astronomical phenomenon. Like, what do you have that can hold perfectly still in the air? Let's talk about
Yeah.
that.
Yeah. Yeah, right.
Someone else suggested, okay, well, Sputnik is the first satellite that we know of. Maybe somebody else had satellites up there. Uh,
Eh, maybe.
Dr. Hassenfatter, one of the scientists who responded to this, she said it's possible, but it seems highly unlikely to me that any nation had multiple satellites in the sky before the Russian Sputnik launch. And it's worth noting it would have to be more than one, right? Like one
Mm-hmm.
satellite would not cause all of this noise. It would have to be a bunch of them. She said also, it isn't that easy to launch a rocket without anyone noticing. You can't just do it from anywhere. And this was a point that I
Yeah.
thought you would probably want to respond to.
Oh, for sure. Yeah. This is like um yeah, this is like launching a skyscraper
Mhm.
into orbit. Like people gonna notice.
Yeah.
But one thing I will say, I can believe uh that either side, US or Russian, would not want to admit that they had launched a satellite and that it was tumbling
Yeah,
uncontrolled.
totally. Yeah, I think the
So,
bigger point is due to the state of the world at the time, it is unlikely that either side could keep it secret from the other. If the US had
yeah.
launched, Russians would have said something about it. They wouldn't have kept quiet, and vice versa.
Yep.
Case in point,
Yep.
nobody kept quiet when Sputnik got up there, and it
Yeah.
arguably would have been to the US's advantage to pretend like they hadn't.
Yeah, absolutely.
Yeah.
Um, another interesting thing is that until like 60, 61, all satellites were either round or like um cylindrical.
Mm-hmm.
Um we didn't have anything that was flat.
Yeah,
The first solar panel was 1958, and I think it was like this big.
totally.
So
Yeah,
yeah,
it is incredibly compelling that all of this predates Sputnik. And it's
yeah,
frustrating that we have to operate with the resolution and quality of the tools that existed in the pre-Sputnik era in order to get clean samples. I
right,
mentioned that she has another paper out there about using the Earth's shadow technique to filter out space junk and human-made satellites. The idea
yeah,
being vanishingly few satellites emit light of any sort. They just
right,
don't. They may reflect light, but if you're
yeah,
looking in the Earth's shadow, you would not expect any space debris or most man-made satellites to show up. So if you still see something there that's behaving like a
hmm,
satellite, but is self-luminous, that's interesting and worth looking
that's
at.
interesting.
Yeah.
Yeah, yeah, it'd be interesting to think about the orbit you would need in order to put a telescope uh, in an orbit where it could consistently look into the Earth's shadow
Yeah.
uh, and image the like interesting bits of the galaxy behind it.
Yeah, for
Um,
sure.
it's interesting.
Yeah, yeah, totally. I hadn't thought about that. Like, how do you escape the sky pollution? Well, you just stay in the Earth's shadow and go a little bit higher than it.
Right? Yeah, like you couldn't put a satellite in geostationary
Mhm.
and just like stay. Well, first off, it wouldn't stay in its shadow because it would continue to precess. But you couldn't just put it there because you'd only see that part of space
Yeah,
in a like fairly narrow beam. Like
yeah,
you have to be off from that a little bit, and it's just interesting.
yeah. I think
But
we
we could
just
do
figured
it.
out why they haven't already done this.
I mean,
um,
it's not actually we have. That is kind of where JWST is.
oh, really?
And if you want to talk more about Lagrange points after this, I would be happy to. It's fascinating.
Okay. So moving
Yeah.
back on with alternate hypotheses and criticisms of these papers,
Yeah. Please.
Mick West, everyone's favorite UFO debunker, was of course poo-pooing these papers early on,
Of course.
arguing that they weren't peer-reviewed. Once they passed peer review, people were like, "Hey Mick, what do you think of them now?" And his response was, "Everyone knows the gold standard of science is not peer review; it's independent replication," which is just like such a spoil sport crybaby response, but
Yeah.
fine, whatever. Gary Nolan responded to him on Twitter like with fully like a laughing emoji. He says, "Listen, like Mick still doesn't get it. Multiple plates showing the same kind of event is replication. It's peer reviewed of unaltered photographic plates. If you want to replicate it, you can look at the plates and do the same study," which is itself a good point. But even more interesting, this is very new. Dennis Asberg, who is co-author on the transient study with Dr. Villarroel, tweeted,
Okay.
"Beatriz showed the phenomena exists using historical plates from October 4th, 1954. Now, a French observatory record from October 3rd, 1954 shows the same transient behavior.
Whoa.
Two observatories on different continents, one phenomena." Now, that's a very exciting
Wow.
claim because that speaks to
Yeah.
peer replication from another observatory,
Yeah.
which is exactly what Beatrice is. This is where I'm going to put a big fat asterisk on it. The source of this is Dr. Simon Holland, who has a YouTube channel that people are very conflicted about. This guy is not actually a doctor. That's just what he calls himself. He has a breathless science channel. It's not bad,
Mm.
but he tends to kind of dive into the deep end on these things. This claim comes from him. He says that when he was talking about Dr. Villarroel, someone who worked at a French observatory at the time reached out to him and said, "We saw the same thing, and there was a news report at the time about it, and they managed to find the video." So what Simon Holland shares is a French language news video that he translates talking about the fact that they found transients. We are multiple steps removed from a like scientifically validated claim that this
Yeah.
observatory has done it. That said, it goes back to what Dr. Villarroel was saying. There is no reason that we could not replicate this study at
Yeah.
multiple observatories. If there is a French observatory that has photo plates from pre-Sputnik, we could go there and do the same thing. Either we
Yeah.
need more observatories to digitize them so that people can do this without going there, or we need funding so that we can send a team of, postdocs to go do
Yeah.
this research in person. But there
Yeah.
is more data out there that they have not looked at that could validate these findings.
That's super cool. Has she talked about has she replied to those tweets about the French
I haven't seen
observatory
her
or
reply to it, but
okay.
like I said, this just happened. Simon posted that video
Yeah.
a couple
Okay.
days ago. Her
Oh,
co-author,
okay.
I think, tweeted 2 days ago. So this is very
Wow.
much developing
It was live.
situation. Who knows what
Okay.
comes of it? I don't blame
Well,
anybody
cool.
who takes anything Simon Holland says with a grain of salt, but he does link to the original source material. He shares it in French, so anybody who speaks French can go read it and see if it says what he
Mhm.
says he says. I don't know. It is another interesting point that arguably bolsters Dr.
Yeah.
Villarroel's claims. Um,
Yeah. So it still doesn't say aliens though yet, right?
yeah, we're getting there. Um, Chuck mentioned that Dr. Villarroel had an interview with the Soul Foundation where Dr. Gary Nolan, who, as I said, we have a ton of respect for, threw a bunch of questions her way. I highly recommend that one. It is like an hour and a half long video, but only about 45 minutes of it is actually Dr. Gary Nolan talking to Dr.
Yeah.
Villarroel. That part is great. Gary Nolan at one point explicitly says, listen, I'm going to throw some alternate hypotheses at you that I think other people might propose, not because I don't know what the answer is. I've read your paper, but I would like you to say what the answer is so our audience is informed about why that isn't a good explanation. The
Yeah.
first thing he said is, what kind of atmospheric effects might have been created by the nuclear tests themselves that would mimic these sorts of transients? Which is a great question, and it's vague enough that it's not getting specifically onto, oh, neutrinos would do this. Like, she's not knocking down individual tests. She's saying specifically, would anything a nuclear test does cause anything that might explain some of your results? Her answer is, we were talking about that might be some kind of glowing fireball or something in the sky. In other interviews, she mentioned fallout, bits of debris from the bombs. Like, there's a lot of things that could be in the sky. She said, however, all of these things are going to be streaking. If a telescope is tracking the stars, they're going to be seen as streaks, not point sources.
Yeah. Makes sense. I did she talk about like radiation or high energy particles at all?
So I didn't read the papers, and in the interviews
Okay,
I
yeah, that's fine.
watched, she didn't mention it. But also,
Okay.
I'm not a scientist, and I may not have understood it
Yeah.
even if she said. It makes sense to
Right.
me to imagine, for example, we do neutrino tests deep underground because we want to
Yeah.
filter out all other particles, and neutrinos will pass through things. Is there something similar where they set off a nuclear bomb in Nevada and
Right.
a high energy particle from that hits the photographic plate in California? I don't know how likely that is. I don't know if that is something that they need to factor in. But her answer to, is there anything a nuclear test would do that might register on your plates, was all of those things would show up as streaks.
Yeah. Makes sense.
Nolan continues. He says, what about cosmic rays? That might explain why you see a correlation with nuclear tests. And Dr. Villarreal's response was, well, then I wonder why we see a correlation with UFO events. And I would also wonder, why do they vanish in Earth's shadow? So getting back to this
That's a really
idea
good
of,
one.
you might have a plausible answer for, this one weird thing might do it. Sure, but it wouldn't go away in your shadow and it wouldn't correlate with UFO events. So it's like, you have to
Yeah.
tick all of these boxes, not just answer one.
Yeah. When yeah, if the high energy particles were coming from the sun, then yeah, they would disappear in the shadow. But it, like, I don't know. You'd have to getting all those particles lining up seems like that'd be really weird. I don't know.
Yeah. Yeah. Again, this is one of those areas where I have to kind of plead ignorance. I'm not a scientist,
Yeah.
but
Yeah.
at no point does someone ask her this and she goes, "Oh shit, that's a really good point." Like, whereas when her peer
Yeah.
reviewers were like, "Hey, you need to show that these are reflections," she's like, "Oh shit, okay, I guess we got to go do a test involving your shadow." Like,
Yeah, yeah.
she confidently and calmly answered, "Yes, we've factored that in effectively." That was the answer that I really
Yeah.
heard. Not worrying about the details. Like, could it be this? No, because X.
Yeah. Right.
Um, this gets back to the thing that I've teased a couple times. She tweeted very recently, I think yesterday, in fact, a really interesting post. She said, any viable hypothesis for the Vasco transients must explain 7 independent observational facts. 1, they have point spread functions similar to stars. Chuck was actually just looking this up while we took our break. What this means is if you take a photo of the reflection of something off of a mirror or a computer monitor, the light source will be shaped like a mirror or a computer monitor, and your computer model can tell that. When they say point spread function, they literally mean these stars look like a single point that is radiating light. The concern, getting back to what Chuck mentioned really early on in this episode about the resolution of these old quality photos and old quality scans of old quality photos, is you may not be able to detect the difference based on how far away this object is. An object that is in orbit, even though if you had a clearer photo of it, you might get a point spread function that says, oh, actually, that's a triangle. In the math of these low resolution photos, it looks like a point. So anyway, point number 1, they have point spread functions similar to stars. With the 1.4 meter telescope optics, this means the sources therefore must be hundreds of kilometers away to avoid blurring, i.e. outside the atmosphere, during the 40 to 50 minute star tracking exposures. Point number 2, they are not present in images taken 30 minutes earlier or 30 minutes later. Point 3, they sometimes appear and disappear in groups. Point 4, some of them are aligned. Point 5, they correlate in time with nuclear tests. Point 6, they correlate in time with historical UFO reports. And point 7, they show a statistically significant deficit inside Earth's shadow. They literally disappear there.
Seems like Dr. Villarroel's 7 observables.
That's a really good analogy, honestly. Like when Lou came out and said that OSAP came up with a list of 5 observables, his point was not anything that shows any one of these is a UFO. His point was, you might have a single object that can do one of these things. You might have something that is very, very fast, for example. But can it also make a 90-degree turn without slowing down? Can it fly through rock as if it was thin air? Can it move from space to air to water without change? Like the point of the multiple observables. Exactly. The more of these you tick off, the more anomalous it is and the less likely it is to be something man-made. Here we have Dr. Villarroel saying, here are 7 things we have observed about these transients that makes us think they are unusual. And any hypothesis you come up with needs to address them. Otherwise, all you've done is said, oh, a balloon might answer point number 1. Anyway, her quote keeps going. She says, no natural or instrumentational explanation proposed so far. And this has been weeks now. So she's seen a lot of criticism come her way. None of the
Yeah.
explanations proposed so far account for all 7 properties at once. Many experts offer explanations that account for one of the 7 points, but are falsified when tested against the others. The balloon hypothesis fails already at the first point. Brief flashes get quickly diluted by the 50-minute exposure. Plate defects don't correlate with nuclear tests, historical UFO reports, or vanish in the Earth's geometric shadow at 42,000 kilometers altitude. Each alignment is statistically evaluated against randomness. The heavily contrived alternatives suggested by some experts were already falsified or falsifiable by the data. At present, the only hypothesis consistent with the full set of observations is that of artificial objects in high altitude orbits pre-Sputnik, and I believe that a significant fraction, around 1/3 of these transients, are such.
I mean, it's certainly worth continuing to look at and
Yeah.
continuing to try and dig in.
Now, Dr. Villarroel, let's get to the point of why we're talking about this on a UFO
Let's get
podcast.
weird.
She says, these results raise a bold question. And yes, you know which one.
Here we go. Let's go weird.
Right? So Dr. Villarroel says, my scientific conclusion from this work that we've been doing is that we see something that shouldn't be there in these images from the early 50s. Something that happens to look very flat and very reflective and in high orbits, probably. That's my scientific point of view. If you ask me about my personal, I'm going to say I think it's artificial and not ours.
I mean, I think it's a fair conclusion that it's not ours. But I do feel like the universe is an incredibly weird place full of science, just like waiting and begging to be understood. So,
Yeah, absolutely. And for the record, she would not disagree with you. In multiple interviews, people have tried to kind of pin her down and get her to say, it's aliens! And she always walks back from that. Even though she's very clear, I think that's likely, she's very careful to leave room for it to be something else. Ross Coulthart interviewed her. We love Ross Coulthart, brilliant Australian journalist who is very active on the UFO beat. He said, are we talking about the possibility of a non-human technology that was surveilling this planet at that peak moment in UFO history? And Dr. Villarroel says, I cannot find any other consistent explanation other than that we are looking at something artificial before Sputnik 1. I don't find any other ways of looking at the data. If I take the pieces together, that some of them fall in a line, that our best cases happen during the Washington, D.C. flap by coincidence, there's temporal correlations with the nuclear bomb tests and with UFO sightings, and on top of it, there's a huge deficit in the shadow of the Earth. For me, this looks technological, but I may be wrong. Maybe there's some new physical phenomenon that they haven't, that nobody knows about yet. But to me, it looks very high tech.
Even if it's new science and not aliens, I'm certainly going to be looking out for new papers.
Yeah, absolutely. Oh man. So I hope
pretty cool.
I hope we did it justice. I was very nervous tackling this because I'm not a scientist. I felt a lot better once I watched 2 different interviews with her and read multiple articles summarizing the results of the paper. And it all kind of boiled down to this idea of there are more transients than we would expect. And the typical they're all plate defects answer is unsatisfying. So working from a hypothesis that they're not all plate defects, she was able to find that they disappear in the Earth's shadow, at least a fraction of them do, and they have a weird correlation with UFO events and nuclear tests. That's really compelling to me. It doesn't mean that it's aliens, but it's sure compelling. And the fact that the reflection profiles, if you're able to say that they are reflections, tell you that they're at this altitude, that they're tumbling, that they're flat, angular, highly reflective surfaces, which aligns with historical UFO reports and descriptions of how they fly. I find it very, very interesting. And I am very intrigued by the fact that these papers were peer reviewed, they were accepted, they were
Mhm.
published. And while people have argued with her about maybe it could be a different answer, nobody's come out and said, you're crazy, you're out of line. This is
Yeah.
clearly all plate defects. Like, she's done a really good job. And Gary Nolan called her out on this in his interview also, of sticking to the science.
Yeah.
Nolan has said repeatedly, this is the way you do it. You don't come to people with
Yeah.
conclusions. You come to people with the data. And the data should have a fairly inescapable conclusion. If they want to come up with an alternate explanation for it, that's on them. But they have to be able to
Great.
answer the data that you have put forward. Dr.
Yeah.
Villarroel has now added significantly to the discussion by proving these things disappear in the shadow and they have a weak but statistical correlation. Anybody who wants to participate in this discussion has to
Yeah.
address that now.
Yeah. I I'm waiting for someone to find new nuclear tests that weren't acknowledged previously
That would be
based on
really
this
interesting,
data,
right? Yeah.
right? Or
Uh,
something like that, some secondary effect.
One of the things that somebody mentioned is at one point, the US was trying to come up with a means of listening for uh, evidence that the Russians had detonated nukes that we weren't seeing. So they were trying to do, like, I forget what it was, radar or satellites or
Mm.
literal audio, but whatever it was,
Yeah.
they came up with a test that they thought would help them find nukes. And they kept seeing them and they were like freaking out. And then it turned out that what they were detecting was like supernovas and magnetars and pulsars. Like, they had made a test so sensitive that it was detecting astronomical phenomena. So we're
Yeah.
definitely in a weird territory here, and
Yeah.
definitely strange things happen when you start playing on the edge of science. But my favorite part of the whole interview with Dr. Nolan was when he tried to pin her to the wall and he said, Beatrice, what do you need to do next? And she's like, oh, like, we're kind of looking into this thing. We're kind of thinking about that. He's like, no, if you were to continue investigating this, what would it take? She's like, oh, I mean, I could probably get it done with, like, he's like, no, what is your dream setup? And you realize that what Gary Nolan is doing is trying to get her to say a dollar figure so that
Mhm.
some rich person who's watching this will go, well, shit, I'll pay for that. And what
Yeah.
she said was 300,000 euros to pay for a single postdoc and undergrad researcher to go to another observatory and replicate the results on their plates. That's
Incredible.
jaw-droppingly cheap.
So affordable. And even better, like they contribute all of those scans to science. Like not
Absolutely.
only have we gotten replication for one thing, we get to
Yeah.
use that for all the things. Like
Yeah.
such a good idea.
So
So worth it.
wherever you fall in the spectrum of interpreting the data here, I think we can all agree that it's interesting and worth
Mhm.
continuing to look at. And there is an easy, obvious next step. Go look at the other photographic plates from the other observatories. And if we
Yeah.
continue seeing the same thing across the board, it's time to start having a pretty significant conversation about what the fuck was in orbit before we launched satellites.
Right. Yeah.
All right. Everybody, thank you so
Incredible.
much for joining us on It's a Very Exciting Time. You can find show notes and more on our website, veryexcitingtime.com, as well as links to our Discord and social media accounts.
And if you'd like to support the show, please check out our Patreon at patreon.com/veryexcitingtime or grab some merch or t-shirts at veryexcitingtime.com/merch.
And Chuck, as always, my wife thanks you for listening to me talk about UFOs so she doesn't have to.